Day to you all and welcome our first class on acid, base and salt. Welcome back to Gravi-cation, your platform for excellence. So we'll be moving straight to our first video series, which is talking about definitions of acid, base and salt, and as well as conjugate acid and base. So we'll be defining acid, base, and salt according to the following individuals. We'll be defining according to Arrhenius. We'll be defining it according to Bronsted-Lowry. We'll be defining it according to Lewis. So we'll be defining acid and base according to these individuals: Arrhenius, Bronsted-Lowry, and Lewis. Now, from the screen, Arrhenius defined an acid as a substance that dissociates to or ionize to produce hydrogen ion or hydrozonium ion. So by the concept or by the word hydrogen ion or hydrozonium ion, we mean having what we call H plus. While hydrozonium ion can be written as H3O plus. So these are the ions that specify that a substance is basically an acid. Any substance that dissociates to produce either an hydrogen ion or hydrozonium ion is said to be Arrhenius acid. Are we together? Now, the definition of a base, we said, according to Arrhenius, a base is a substance that dissociates to produce what we call hydroxide ion. So hydroxide ion is written as OH minus. So any substance that dissociates in water to produce an hydroxide ion is referred to as a base. So we have simple examples of Arrhenius acid and base. Acids that mostly contain proton, such as HCl, such as H2SO4, such as H3, right? PO4 rather. All these are acid. We also have organic acid, compounds that have the functional group COOH. So any compound that has the functional group COOH is referred to as an organic acid. So now, when you look at these compounds, they have each has protons to what? To donate. They have protons to donate. So for that reason, they will be referred to as acids. They will be referred to as acid. What type of acid? Arrhenius acid. Based on the other hand, when they dissociate or dissolve in water, we say they have the tendency to produce an hydroxide ion. So very good examples of bases. We have KOH, that's potassium hydroxide. We have NaOH, that is sodium hydroxide. We also have CaO. We have compounds like sodium oxide. They are all referred to as base because when they dissociate in water, they tend to produce what you call hydroxide ion. They produce hydroxide ion. So this is Arrhenius' definition of acid: substance that dissociate to produce hydrogen ion. Base: substance that dissociate to produce hydroxide ion. Now we move further to the other definition of an acid and base, which is according to Bronsted-Lowry. Now, Bronsted-Lowry defines an acid simply as a proton donor. That is to say, an acid should be any substance that has the tendency of giving out proton. So when we say proton, what we're trying to say here is the word hydrogen ion. So an acid is any substance that can give out this hydrogen ion. It can donate this hydrogen ion. Good examples there is that we can have what? H2O. We have what? HCl. We have the likes of them. all substances that contains hydrogen, which are acidic in nature, and can donate these protons are referred to as what? Brostolauris acid. This time around, they are not dissociating in water. They are donating these protons. Now, a base is a proton what? Acceptor. A substance that accepts what? A proton. That's what we call a base. A substance that accepts what? A proton is what we call a base. So in the likes of that, I think we'll be having OH minus as a base, because when it accepts proton, it gives us water. We have ammonia as a base. When it accepts proton, it will give us ammonium ion. Are we together? So in this aspect now, water can be an acid, can be a base, because when water accepts proton, it is going to give us hydroxonium ion. So any substance that accepts a proton is referred to as what? Brostolauris base. While a substance that gives out proton is referred to as what? Base. So please take note. Proton acceptor, proton donor. That is how you define an acid and a base. Now, very fast, we will now be moving to the third definition of an acid and a base, which is according to Lewis. Lewis defined an acid as an electron acceptor. That is to say, there is an orbital that is willing to accept an electron. So when a substance has an orbital willing to accept an electron, that substance will behave as an acid because it is going to be accepting electron. While a base is a substance that does what? That donates electron. That means they have sufficient electron. They want to donate electron. So Lewis defines acid as an electron acceptor, while a base as a what? Electron donor. So very good examples of Lewis acid include hydrogen ion. Hydrogen ion has an empty orbital that can accept what? Electron. Also hydrozonium ion can accept electron. Are we together? Aluminium chloride, iron trichloride, calcium chloride. They are all examples of what? Lewis acids. Aluminium chloride, iron trichloride, calcium chloride, which are all electron acceptor. Now, a base, on the other hand, we said is what? An electron donor, meaning that they are sufficient in electron. They have sufficient amount of electron. So very good examples of bases are water. Water has lone pair of electrons. Ammonia also has what? Lone pair of electron that it can donate. Hydroxide ion has electron that it can give. So most of your anions in general are Lewis bases, while your cations in general are Lewis acid. Anions are Lewis bases, cations are Lewis what? Acids. Are we together? Cation is an atom or group of atom that has a positive charge, while an anion is a substance or group of atoms basically, or an atom that has a negative charge. So according to Lewis, acid is an electron acceptor, that's the take home, while a base is an electron donor. Now, with the knowledge of this, we need to now look at what we call conjugate acid and base. The idea of conjugate acid and base arises from Brostolauris definition, right? What is this telling us? Now, according to Brostolauris, an acid is simply a proton donor. So if this is an acid, let's say this is an acid, HCl, and then it donates a proton. What we mean by donating a proton is that it gives out a proton. It will be having a species like this. So this particular acid, which has given out a proton, what is left of the acid is referred to as a conjugate base. So a conjugate base is simply an acid that has lost its proton. That is to say, this chloride ion here is referred to as what? A conjugate base, because it's an acid that has lost its proton. Now, a conjugate base in the other hand is a what? Is a base that has accepted a proton. A base that has accepted a proton. Let's use the idea of ammonia. So when ammonia accepts a proton, we will be having ammonium ion. So ammonium ion here is our conjugate acid, because it's obtained from a base. What is the base? The base here is what? Ammonia. The base here is ammonia. The base here is ammonia. So this ammonia has accepted a proton. It has accepted a proton to give us that species. So a very quick one. So this is 3 sample questions. So we'll give you like probably 2 minutes to identify the acid, the conjugate acid, the conjugate base from each set of questions. So, and question 1, what is your conjugate acid? In question 2, what is your conjugate acid and base? In question 3, what is also your conjugate acid and base? All right, I think by now we should have come down with our answers. So for question 1, our acid is an organic acid which is called ethanoic acid. So this is ethanoic acid. So this ethanoic acid has lost its hydrogen from its functional group here, thereby giving us this species. So this is our conjugate base because it is obtained from an acid, while this is our conjugate acid. All right. Now, in the second example, our acid is HCl. It has lost its proton to water, which is the base in this case. So when acid has lost its proton, what is left of the acid is referred to as conjugate base. So Cl minus, which is our chloride ion, is a conjugate base, while our hydrozonium ion is our conjugate acid. And in this last example, you see that water here is our acid, while ammonia is our base. Now, from what we've seen here, we've seen that what? Ammonia has gained a proton to give us ammonium ion, while water has lost a proton to give us hydroxide ion. So hydroxide ion is our conjugate base, while water is our acid, ammonia is our base, while ammonium ion is our conjugate acid. So please take note, your acid and your base are always at the right hand side, while your products are always at the left hand side. So please take notes. See you in our next class. Bye bye.